Hey, let's make a recap about our programming assignments about the deep regression and smarter features. So, here's what we did. The goal of the assignment, the main objective of this assignment was to build a simple neural network model using PyTorch that can predict delivery time in minutes based on a real-world style. Like, we had inputs there, like distance in miles, time of day, is in hours, whether it is a weekend, whether the order is during rush hour. To achieve this, we went through a full machine learning pipeline, like from the very first beginning uh, of the machine learning pipeline, like for example, exploring and visualizing the raw data. So before we create the model, we focus on understanding the data. So we did is we load the delivery data from the CSV file. We visualize delivery time versus distance, differences between weekday and versus weekend, effects of rush hour versus non-rush hour. Why this matters? Because visualization help confirm realistic patterns, such as longer distances, longer delivery times. Rush hour deliveries generally take longer. Weekend behavior differs from weekdays. This step justifies why we need the feature engineering, not just raw inputs. So here it comes. We have a feature engineering, creating the rush hour feature. So we create a rush hour feature function. We implemented logic to determine whether a delivery happened during rush hour. So the rules applied. Rush hours occurs only on weekdays. So time windows, morning rush, evening rush. The output would be 1 if it is rush hour and 0 if not rush hour. So why this is important? Because rush hour is not explicit in the data set. We created a new meaningful feature from existing ones. This helps the model learn nonlinear real world behavior. So this function will later reuse in the data preparation and prediction, reinforcing code reusability. So let's in preparing the data for the model. So we have a prepared data function. So this step converted raw CSV data into model ready tensors. So here we go. We have a column slicing of distance, time of day, week, and flag delivery time or the target. So the tensor, we reshaped the tensor. We converted the one-dimensional tensor to two-dimensional column vectors using unsqueeze 1. So feature assembly. So we combined distance, time, weekend, and rush hour. Result in a 4 feature input in the tensor. So the targets will be delivery time stored in a separate tensor. So this matters because neural networks expect numerical tensors with consistent shapes. This step bridges raw data to machine learning model. So normalization of continuous feature. We normalize the distance and the time of the day. So the formula we use is the x minus mean divided by the standard deviation. Why normalization is important? Because we prevent the large values, like for example distance, from dominating the training. Because if we let um, this kind of feature, like for example, we have a feature of distance. We will have a mathematical biases, which means the model would uh, could have more mathematical bias because we know that distance is larger than any for among all of the feature that we had. So we improves using the normalization. We improves training stability and convergence speed, essential for gradient-based learning. So category of feature like weekend rush hour, we're not normalized, which is correct. Building the neural network model. So initial model function, we define the model architecture, optimizer, loss function. So the model structure is we have a 4 features of input. Okay. So for so the input is 4 features. So we use the linear activation, the linear, okay, for input 64 outputs, and we have an activation function ReLU. Yeah. So additional choices, we set an optimizer SGD, which learning rate is 0.01. The loss function is mean squared error, or MSE. Why this isn't work? Because we'll introduce non-linearity. Multiple layers allows the model to learn complex relationships. Mean squared error is appropriate for regression problems. Training the model, we train model function. This step implemented the training loop. What happens each epoch? So 1, we forward pass model prediction, loss computation, MSA, or the mean squared error. Optimizer, we had an optimizer at zero gradients. So we have loss that backward, compute gradients, optimizer each step, update weights. So the training details, we trained 15,000 epochs. Loss values decrease over time. Yeah. So the more the loss values decreases, the more the model would become more accurate. So it will be fit of the data that we're trying to predict. So the demonstrates this matters because demonstrates correct gradient descent learning, confirms that the model is actually learning from data. Evaluating our model performance. So the actual versus predicted plot. We visualize the model predictions versus the true delivery times. Remember that we had to set the target values because we're going to use it to evaluate the model performance, whether we had our model is accurate versus the actual data. Okay, so a reference line is our model. If if we are trying to predict in our model, it will give us the best result as possible. So our reference line is for perfect predictions. So the interpretations points close to the diagonal good predictions. Spread shows normal prediction error. Confirms that the model learned meaningful patterns. So making real predictions with validation. So prediction function, this is the final step simulating a real world usage. What it includes: input validation, distance limits, operating hours, valid weekend flag, feature engineering, rush hour, normalization using training statistics, model inference using torque.now gradients, clean formatted output table. So this is important because it shows how machine learning models are used outside training. Mimics production style prediction pipelines, prevents invalid or unrealistic inputs. So here's the big pictures of what we have learned or what we did in the programming assignment last last activity in our lesson. So we practiced the end-to-end machine learning workflow of how we what we actually did the pipeline of the machine learning. So the feature engineering, tensor manipulation with PyTorch. So the feature engineering is like you're going to create a function uh, of the column of your the data frame. So tensor manipulation, we had a tensor manipulation with PyTorch, neural network design, training loops and optimization, regression evaluation, so and turning a trained model into a usable prediction system. So this assignment is not just about the code; it demonstrates how real machine learning systems are built step by step.